Hello, I'm James Ingram. In part 1, we tried to point out the details of this 3-train point-to-point system. In this part 2, we'll show it operating on 2 different public displays and also review the command file at the end of the video. Note that we did this 3-train point-to-point operation in the earlier year 2020 video number 829 using 3 O-gauge Locos. But this video number 850 demonstrates a better control board design and a more flexible command file with the option to run any combination of the 3 Locos. Here's that same automatic point-to-point system operating at the November 2025 Denver Xmas Show, and here we've got all 3 diesels operating on it. You can see the first train with the bear is pulling forward and just stopped. Now back there at the other end we'll start the second train up, and we've got all 3 diesels running on it this time. Again, watch that little light there. It'll change briefly to red as the train interrupts the beam, which closes a relay and tells the controller that the train passed it. And you can see with that Heartland Mac, we've got a strobe light on the top, and the strobe light kind of gives the appearance of action, even though though the locomotive is not moving. Now here's the third train coming forward with a Bachmann Davenport diesel, and that'll pull up and stop. Now they'll wait there about 4 seconds, and then the system will start in reverse. There goes the third train backing up, crossing the detector, heading back toward the other end of the track. And at the minute the Heartland Mac will start up, going in reverse. And the DGRS, Denver Garden Railway Society, was kind enough to let me put this on their layout. It's kind of disruptive to their normal system of operations, because normally they just got loops to hook up, and with this system I've got to have that detector out there in the center, which is kind of a hazard. Everybody has to walk around and not trip over it or step on it. So thanks to the show chairman, Scott Vance, for allowing me to put this stuff on their layout and kind of disrupt their operations. Now there's our third engine, or I should say really the first engine, backing up, and when that gets to the end of the track they'll wait for about 17 seconds, and then the cycle will start over again. There's our controller hidden over on the side underneath the table. This is sort of our work table where we have the commands and the pro cab to do programming if we need to, and the power cab that's running it. Here's the whole layout operating. Our point-to-point system is operating over on this far end. Rain Show, April 2026 in Denver, Colorado. Here's our automated point-to-point track running from down here up past these 2 trains to the bumper. And here is our center, which is a Z-Stuff infrared detector. And we've got what we're calling train 2. in train 1, and then sitting back under the table here is our NCE controller that's controlling it all. Here's a closer look at our controller. The DCC controller just started that train carrying the bear. Now when it passes in front of that Z-stuff detector, the controller will start a time delay of about 12 seconds. And when that 12 seconds elapses, the controller will send a command to stop that engine, which it just did. Now the trains will wait for about 4 seconds, and then the controller will start that second train, that blue Steins engine. And when that train passes in front of the Z-stuff detector, you might be able to see the light change to red. When the train interrupts the beam, it starts a time delay of about 8 seconds. And when that 8 seconds elapse, it stops that train. Now it waits about 4 seconds or so, and then it starts backing the second train up, and the same process happens in reverse. When that train interrupts the beam and the light changes to red, it starts another time delay to park that train back on the other end of the track, which will happen in a second. Now it just issued a speed 0 command. Now it'll start the first train and run it backward. And again, when it reaches the Z-stuff detector, the beam will be interrupted. You'll see the little light will change from green to red momentarily, and the controller will start another time delay slightly shorter to park that train at the end of the track. Then they'll wait there about 17 seconds or so, and the process will repeat. This point-to-point system was supposed to run 3 diesels, but we had problems with 2 of our diesels, and we had to substitute that blue Steins steam engine. The earlier part 1 of this video goes into more details about how this point-to-point system operates. The 5-part video 816 tries to show you how to use this programmable controller. The 2-part overview video 844 shows you examples of things you can do with this controller in N gauge, HO gauge, S gauge, O gauge, and large scale. We're looking at the command file for this setup, and this command file can be found as a PDF in the documentation album for this video 850. On our first page we have some notes, and up here is a sort of a table of contents. There's about 7 pages to this documentation file. My page numbering is messed up, so it goes from page 1 to 2, then 1 to 5 again, but there's about 7 pages total. Here's our sketch that shows how the hardware fits together. We have over here on the lower left, we've got DCC power coming in, and it goes onto the control board to power these 4 NCE light-its, which light up depending on which train we're running. And in these, this power also goes out to the track. And over here toward the lower right, we've got our NCE mini panel, which is our DCC controller that's controlling this whole thing. And then we've got a Atlas number 56 push button, which we use for our start button and our reset button. And we've got 3 Atlas, up here we've got 3 Atlas number 205 slide switches that are hooked up to various inputs of the mini panel. And all these do is just ground an input when we push them down. So that's how you communicate with this thing. You ground an input if you want it to do something. And then the program, when you run the program, you check if that input is grounded or not. And with all these slide switches, we can run any 1 or any 2 or any 3 of the Locos, and we can run them both ways, which we normally do, where we can run them just one way only. And this button is what we call a repeat switch that controls if it runs more than one time, and this controls whether we have the announcements on or off. And this button here we use to control more distance. If we turn this button on, we could have the trains run out farther. And this sketch shows an LGB track contact, which is what we used in part 1. In this part 2, where we were using this on displays, we used a Z-step detector, but it works essentially the same way. When the train goes past the detector, it grounds an input, which happens to be input number 6. It goes back on these wires to input 6 on the mini panel, so that's how it knows the train passed the detector. And keep in mind, we actually could, if we wanted to be ultra precise, you could use 6 detectors, 3 on this end and 3 on this end, but it would be a lot more wiring. So to keep the wiring as simple as possible, we use just 1 detector for all 3 trains in both directions, and we can use time delay on each side of the detector to stop the loco. In other words, when the loco, say this is the first one, goes past this detector, when the mini panel, when the relay is closed and the mini panel knows the train went past the detector, we start doing a time delay. In this case, it shows 5 seconds, so it runs 5 seconds further. Or if we close the more distant switch, we add another 4 seconds and it runs 9 seconds total. So this isn't 100% accurate, but it's reasonably close most of the time. Now we're on the third page, which is reference info. And up here we got a chart, and this basically shows us what our inputs are doing. We've got 31 inputs in this mini panel, and we're using various ones to run various little programs that make this whole thing work, and that's what this kind of tabulates. And again, it's just basically sort of a reference chart. Notice we're actually using input 31, which I'd rather avoid, because input 31, I believe, executes upon startup, so you got to be careful what you put in there, or it can get into problems. But in this case, I've got end statements in it, so it seems to work okay. And then this second section is just a tabulation of what the push buttons and slide switches do. And this is kind of redundant to the sketch we just looked at a minute ago, but it tells us what slide switches are controlling what programs. And in this third section, this is probably the most important thing on this page, our configuration settings. And we basically leave them all set at the default except for 2 of them. Memory address 3, we change that. The default is 0 over here. We change that to 1. So we change that to 1, which gives us continuous memory for inputs 1 and above, all the way up through input 31, which is the way we normally use this for automatic control type stuff. And in memory address 4, we're disabling, again, the default is 0, we're changing that to 2, and what that does, it disables inputs 2 and above, so the mini panel won't pull any of the upper inputs. It'll pull input 1, which is where our push button is connected, and we need it to pull that input, so when we push the push button, it senses it, so to speak, and starts to program, but we don't need it to be polling inputs 2 and above. And so that's the memory, the 2 changes in the memory configuration we make. And in this last section, these are examples of commands, and I just use this because I've got examples of all the commands I use, so I can see what I need to change to get a particular command. And this is derived from the mini panel's instructions. For me, it's just easier to make this little chart and use this rather than digging through the instructions all the time. Here's the 4th page of this file, which is where the actual commands start. And up here at the top, we set our 2 status lights green. We have a main status light, and then we have a second status light on the announcement decoder board. We set both of those green. And then switch 10 controls this first program, which is whether or not we make the announcements. This is supposed to represent an announcer here, but if switch 10 is closed, then we go ahead and make the station departure announcements. If it's open, we skip over this section and go directly to running a loco. Now, switch 14 controls our first loco. So if this switch is closed, we go through these steps to run the first loco to the other end of the track. If it's open, we skip over all these and get down to the next loco. But assuming switch 14 is closed, we do these commands here to get this loco turned on and started, and then we wait till it crosses the detector. That's what this note's telling us, and then we go through these steps to blow the horn for 3 seconds, and after that happens, we start our time delay. In this case, it's 5 seconds, and then we stop the train, and there's another delay before we start the next engine. And we have that switch 12, which is here, and that controls the switch 12 controls adding the extra delay. So switch 12 is closed, we add an additional 4 seconds to how long this loco runs to make it run further. So that takes care of our first loco, and then we can go down to the second loco, and it basically works exactly the same. We got this switch 16 controlling the second loco, and if that's closed, we go through the same steps to run that, and if it's open, we skip over that loco. Now we're on the fifth page of the command file, and we're running the third loco, and that's controlled by switch 18. If that switch is closed, it'll run this third loco to the far end of the track, and we go through the same commands as before. So at this point, we've got all 3 locos down at the far end of the track, and we're ready to run them back, and that's what this big red box is trying to highlight. We're going to start running things back in reverse. And so we run that same loco. The last one we ran forward's got to be the first one we run in reverse. So that's controlled by switch 24 here, and it repeats essentially the same commands, just running in reverse. Now, one thing to note is we're using different switches for forward and reverse. For this third loco, we use switch 18 to control whether it runs forward or not, and switch 24 to control whether it runs in reverse or not. We could just use one switch. It would be less complicated, but by using 2 switches, we can have the loco just go down to one end and stop. And this is handy, say if you want to run just this loco, which is the last one, you got to get the first 2 ones out of the way, so you can run the first 2 to the far end of the track and park them by turning the switch off the next time you run the program, and then you run the program with just switch 18 and just switch 24 closed, and the other switches for the other locos left open. So that'll run just this loco back and forth, and the other 2 will be out of the way. Here's page 6 of our command file, and this runs the first 2 locos back to the original starting point. These were the first 2 out, so they're going to be the last 2 coming back. This is our middle loco controlled by switch 22, so these commands run it back to its original starting point. And then switch 20 controls what was the first loco out and the last loco to return. Switch 20 controls that loco. So when these commands here are all completed, all 3 locos will be back to their original starting point. So we go to the last page of our command file, and we have what we call our repeat or shutdown test. And the first part of this, it actually is the test actually starts here, but what we've got here is we blink the LED on the mini panel, the controller. And what happens if is if there's no locos selected, no announcement selected, but we have the repeat switch closed, the program will just cycle through all 31 inputs and keep repeating itself without running any trains. And that'll cause this light to blink. That's what this accessory 2000 norm command does here. It blinks the light on the mini panel. Now, if we block the detector, and that's what these lines here are about, if we block the detector, it does these commands. It adds an extra delay of 3 seconds when the detector is blocked. So the light blinks but at a slower rate, and that just confirms we're communicating with our detector. Now here, the heavy red line is where we do our test the repeater quit test. And what this does, if input 9 is closed, it'll repeat, goes back to input 2 and starts everything all over again. If it's open, it'll jump down to here and we'll do what we call our shutdown commands, just turn all our status lights from green back to red, and finally a terminate command at the end. And again, these is input 1. You'd like to avoid it if you can, because these, I understand, get executed upon startup, the 4 commands that are in input 31. But since our last command is an end, when this thing starts up, it'll try to do these 4, and it'll terminate anyway, so we can program it or whatever we need to do with the controller. And then down here are some additional notes about the particular logos. Of course, you would most likely be using different logos, so you'll have different stuff. But this is just a bookkeeping section for what function does what activity on the different logos, since they're not all 3 the same. They got different decoders and stuff in them.